Alright, in the last lecture we have learned what's analogy behind big O notation. Now here we will look at different notations that are used in academics to describe runtimes. But in the industry people tend to use big O. To understand different notations that are used to measure the performance of algorithm, let's look at this real life example. Okay, let's say we want to buy a brand new car. And obviously we want to know about the performance of car, which means that we are interested in how many liters of petrol it takes to drive 100 miles. Now in case of car, there is not a standard answer for this question. Even though in any car's manual, it might mention that, for example, it takes 70 liters of petrol for 100 miles, this information is not direct, because a car can perform differently based on the condition. This number can be different based on which condition you are driving the car. So if you drive your car in city traffic, it's obvious that it takes more petrol to reach 100 miles than when we drive it on the highway. And there might be situations in which we drive a car in mixed condition, both traffic and highway. So let's imagine that it takes 20 liters to drive 100 miles in city traffic, 10 liters on highway, and 15 liters on the mixed condition. So here we can easily see that the same car can perform differently based on the condition that we drive. So similarly, algorithms can perform differently based on the condition that is given. We might have three scenarios in case of measuring performance of any given algorithm. These are the best case, worst case, and average case. So let's say for an algorithm, it takes 1 minute to execute in the worst case scenario, but in the best case scenario, it might take 5 seconds to execute, and finally in the average case scenario, it might take 30 or 35 seconds to execute. So with the help of these notations, we can define the best, worst, and average case of algorithm. Now as an example, let's examine quicksort algorithm. So those who don't know what is quicksort algorithm, you don't need to worry about it, because I will provide detailed information in sorting algorithm section of this course. But for now, you just need to know that it is an algorithm that sorts unsorted lists based on selection of a random number as a pivot number, and then we are swapping the values. Now let's look at this example over here. So here, the first thing that we are doing, we are selecting a random number as a pivot number. So in this case, for example, we are selecting rightmost number, which is 5. Then we are placing left and right markers. So we are placing left markers on the left side and right markers at the right side. Then quicksort use these markers to repeatedly perform rounds of operation recursively. So the left marker moves right, and in each step compares the number with the pivot number, and it stops when it reaches a number that is greater or equal to pivot number. So in this case, the first number is 6, so this means that it's greater than 5, so we are not moving left marker. But in case of right marker, we are checking and looking for the number which is less than pivot. So in this case, 8 is greater than pivot, we are continuing to 9, then 9 is greater than 5, we are continuing to 3. So in this case, we see that 3 is less than 5. So this means that we need to swap these values over here. So 3 will move to the place of 6, and 6 will move to the place of 3. So these operations will repeat until all elements get sorted. So in the best scenario, in the best case, all elements are equal, and we will pass through all elements, and we will pass through all elements of this array only once. So if the number of elements is n, so the time complexity in the best case will be O(n). Now in the worst case, if we are unlucky and the pivot is repeatedly the biggest number in the array, so the time complexity will be O(n squared). Now in the expected case, which is the average case, sometimes the pivot number will be high, sometimes the pivot number will be low, so it will not happen over and over again. So this means that in the average case, it might take O(n log n time complexity. Now hopefully with this example, everything is clear. Based on the condition, this sorting algorithm might perform differently. Now to express the different scenarios of algorithm, there are different big O notations. Now the first one is big O. It's a complexity that's going to be less or equal to the worst case. For example, if you want to sort 1000 numbers, big O measures the maximum time that we need for this sorting. Let's say we need a maximum 10 seconds to execute this algorithm. This means that we will never exceed 10 seconds. So it can be 8 seconds, 9 seconds, but we will never exceed 10 seconds. But in terms of big omega, So its complexity that's going to be at least more than the best case. It's different from the big O. Here we measure the minimum time that we need to execute an algorithm. So there might be cases we want to know about the minimum time of algorithm execution, which means that if the base case scenario for executing an algorithm is 2 seconds, in terms of big omega, it will never be less than 2 seconds. Now the third type is big theta. It's a complexity that is within the bounds of worst and base cases. This means that if we have an algorithm with the maximum execution time 10 seconds and the minimum execution time with the 2 seconds, and in terms of big theta, the average time will be 6 seconds for execution. Okay, to make things more clear, let's look at this example over here. So let's imagine that we have an array of 1 million elements and our goal is to find a given number within this array. So if we want to search for a number which is located at the end of this array, we basically check each number one by one till we find the searched number. So let's say the time that we need to visit each cell is 1 millisecond. So the time that we need to visit all of them will take n multiplied with 1. So n is the size of array. Now how can we represent this searching process in terms of notation? So in terms of big notation, it's going to be On, because we need n milliseconds to find the number that we are looking for. So it's going to be On. This means that the maximum time that we need to find any given number within this array is n. So it will not be more than n. So it's not going to be n plus 1, n plus 2. So the maximum time is n. So in terms of big O, it's going to be On. Now let's look at how can we express this in terms of big omega. So in terms of big omega, it's going to be omega 1. This means that the minimum time that is required for finding a given number is 1. So it will not be less than 1 to find any number within this array. For example, if you are looking for 5, you see that the 5 is first element, so it will take only 1 milliseconds to find 5 from here. So we cannot find any number less than 1 millisecond. So in terms of big omega, the best case is 1 second. Now let's look at how can we express this in terms of big theta. In terms of big theta, it will be theta n divided by 2. This is average time that is needed to find any given number. This is because for finding different numbers, we might need various units of time. So if we take the average of these numbers, it's going to be theta n divided by 2. So we need to know all these 3 notations for academic purposes. But when it comes to interview, we are only interested in big O, because we need to find out in worst case how our algorithm works, because it will not take more than this case. So this is all for this lecture. So in this lecture, we have learned different types of notations, and we have learned that for interviews, we are only interested in big O.